There are giant planets. There are hellish planets. And then, there's WASP-12b, a world so extreme it defies the very rules of physics. A place so unimaginably hot, it's literally evaporating into space. A planet being consumed by its own star second by second, and the craziest part, it shouldn't even exist. WASP-12b is not just another exoplanet in a distant galaxy. It is a hot giant, a true cosmic aberration that defies all our expectations about planets. Located about 600 light-years away from Earth, it is a perfect example of how diversity in the universe knows no bounds, showing scientists more than they thought was possible. This exoplanet belongs to the category of hot Jupiters, which are giant gas planets located very close to their stars. What makes WASP-12b particularly fascinating is its proximity to the star it orbits, called WASP-12. It is so close to this star that its surface temperature reaches around 2,500 degrees, which is incredibly hot, hotter than many stars in our galaxy, such as some red dwarfs. To give you an idea, Jupiter, which is a giant planet in our own solar system, has an average temperature of around 180 degrees Celsius. This means that the temperature of WASP-12b is over 2,500 degrees hotter than Jupiter. Now, with all this proximity, one crucial characteristic comes into play. WASP-12b's year lasts only 24 Earth hours. In just a single day, the planet completes a full orbit around its star. This may sound fast, but it is a direct consequence of how physically close it is to its star and the greatness of its orbit. This behavior is a perfect example of how gravity dramatically influences the characteristics of an exoplanet, modifying its rotation and relationship with the star it orbits. With this extreme heat, WASP-12b's surface is like a giant furnace, making it practically impossible for any form of life as we know it to survive in such a hostile environment. The atmospheric pressure and scalding temperatures cause dramatic effects on its atmosphere, which seems to be in a constant state of transformation. Imagine an atmosphere that is literally vibrating with intense heat and constantly expanding due to the massive amount of radiation it receives from the star. But perhaps the most interesting aspect of WASP-12b is the way it is being consumed by its star, a rare and intense interaction. WASP-12, the star it orbits, is sucking the atmosphere of WASP-12b with colossal gravitational force. In fact, the planet is literally being eaten away bit by bit. The heat from the star causes the planet to lose mass at an alarming rate, generating massive gas and vapor flows that are pulled into the star, forming a structure resembling an accretion disk, something more commonly observed around black holes. The interactions between the star and the planet are so intense that the shape of WASP-12b has been permanently modified. Instead of being spherical like Earth or Jupiter, it has taken on an ellipsoidal shape, meaning it is stretched out by the gravitational force of the star. If you could observe WASP-12b up close, you would see that it is no longer round but more egg-shaped. This is the effect of the immense gravitational force it experiences while orbiting its star at an extremely high speed. This process of continuous destruction is not something that will happen overnight. Scientists predict that in about 10 million years, WASP-12b will be completely devoured by its star, disappearing forever. This estimate is based on the amount of energy being transferred to the planet and how the exoplanet's orbit is shrinking over time, causing it to get closer and closer to the star. In the not-too-distant future, if the planet survives that long, it will likely disintegrate completely. But the story doesn't end there. The incredible amount of radiation emitted by this exoplanet also makes it extremely dark, absorbing 94% of the light it receives. This makes it nearly invisible to the naked eye, except for the immense heat it emits. If you could look at WASP-12b from a safe distance, you would see it as a shadowy object, reflecting almost nothing but glowing intensely due to its high temperature. Additionally, the atmosphere of WASP-12b is constantly being ripped apart and destroyed by its star, so it doesn't maintain a stable layer of gases like Earth does. The escaping gas travels into interplanetary space, creating a visible trail of cosmic particles around the planet. This process of the atmosphere being sucked away and its gradual extinction is one of the most fascinating aspects of this entire story. It's as if the planet is being continuously dissolved, with the star consuming its substance. Moreover, Throughout WASP-12b's orbits, scientists have discovered that the star's light is not constant. Every time the planet passes in front of the star, the light reflection modes change. This happens because the distorted shape of the planet alters how it interacts with the light from the star, creating a unique visual phenomenon that can only be observed in planets of this type. WASP-12b is an impressive example of how gravitational fields, extreme temperatures, and cosmic forces can alter the trajectory and life of a planet, making it a true natural laboratory for understanding the behavior of celestial bodies in extreme conditions. For scientists, it is more than just a distant planet. It is a window to understand how the universe can shape and destroy even the largest and most massive planets. While the physical destruction of WASP-12b is dramatic, what happens beneath its turbulent clouds is equally fascinating. The planet's composition is not just gas and heat. Scientists believe that WASP-12b has an unusual chemical makeup, one that challenges traditional models used to describe gas giants. Unlike Jupiter or Saturn, which are mostly composed of hydrogen and helium, WASP-12b's atmosphere contains carbon-to-oxygen ratios that are off the charts. Some early spectroscopic analyses suggest a carbon-rich atmosphere, so rich, in fact, that astronomers once speculated the planet could contain diamond-like structures deep within its core, formed under extreme pressure and heat. While that idea remains unconfirmed, it hints at the diversity of planetary chemistry that exists beyond our solar system. The use of transmission spectroscopy has been crucial in unveiling the secrets of WASP-12b. As the planet passes in front of its host star, starlight filters through its atmosphere, allowing instruments like the Hubble Space Telescope to detect specific wavelengths absorbed by various gases. This technique has revealed the presence of water vapor, methane, and even metal oxides, all swirling in an unstable and ever-shifting mix. The intensity of heat causes many compounds to break apart, recombine, and create dynamic atmospheric layers that change with every orbit. It's a world where chemistry happens at hypersonic speeds. But WASP-12b's unusual darkness remains one of its most mind-bending features. It reflects just 6% of the light it receives, making it one of the darkest planets ever observed. For comparison, coal reflects more light than WASP-12b. Scientists believe that its deep black color is due to the absence of reflective clouds and the presence of atoms like titanium and vanadium oxides, which absorb light instead of reflecting it. The intense heat may prevent the formation of high-altitude clouds made of silicates or reflective crystals, common in other exoplanets. This makes WASP-12b not just dark, but uniquely dark, as if it's cloaked in an energy-absorbing shroud, adding another layer of mystery. WASP-12b appears to be tidally locked to its star, meaning the same side always faces the star, just like the moon with Earth. This creates a permanent day side and a permanent night side, with extreme temperature differences between them. On the day side, molecules are broken apart into ions by radiation, while on the night side, they may reform briefly, only to be dragged back into the furnace-like conditions of daylight. This brutal cycle produces atmospheric supercurrents, winds, that may reach speeds over 7,000 km/h, moving gases from one side of the planet to the other, in a relentless attempt to equalize the temperature. These high-speed jet streams contribute to the planet's deformation and make its climate one of the most chaotic in the universe. In terms of magnetism, WASP-12b may possess a weak or absent magnetic field, which would help explain why it's losing its atmosphere so rapidly. On Earth and Jupiter, magnetic fields act like shields, deflecting solar winds and protecting the planet's atmospheres from erosion. Without such protection, WASP-12b is vulnerable to every blast of stellar radiation, like a sandcastle under a constant barrage of cosmic waves. Some astronomers even suggest that the planet's magnetic environment may be so overwhelmed by its star's influence that its own field is compressed and ineffective. What makes WASP-12b even more significant is its role in helping scientists build evolutionary models for hot Jupiters. It's an extreme case, but by studying it, researchers can understand how gas giants migrate, how they behave under irradiated conditions, and how planetary systems evolve around metal-rich stars. WASP-12 itself has high metallicity, which could be a factor in the unusual properties of its planetary companion. This connection is still under study, but it suggests that stars with specific compositions might birth planets with equally unique characteristics. Lastly, WASP-12b's destruction provides a rare chance to observe planetary death in real time. This is not theoretical. Astronomers have monitored the planet's orbital decay, watching it inch closer to its doom year by year. Precise timing data has shown that the planet's orbit is shortening at a detectable rate, offering a live demonstration of what happens when a planet gets too close to its star. No other known exoplanet provides such a dramatic, measurable countdown to oblivion. As science continues to evolve, WASP-12b stands as a cosmic laboratory, teaching us about planetary chemistry, dynamics, and destruction on a scale we never imagined. And while its fate is sealed, its legacy is just beginning to shape how we look at planets beyond our own small solar neighborhood. This exoplanet is incredibly dangerous because it brings together lethal conditions: scorching heat, glass storms, intense radiation, and toxic atmospheres. A true cosmic hell. Just attempting to observe it closely would push our technology to the limit. It's a stark reminder that the universe is not only beautiful, but also brutally unforgiving. If you love diving into the wildest corners of the cosmos, make sure to subscribe and hit the bell. There's still so much of the universe left to uncover.